Welcome to Science Spectrum with Don. This is the ninth part of the third lecture in measurements of physical quantities, and specifically we are so far talking about the measurement of length. So in the previous lecture we discussed about the principle, right, by which the Vernier caliper works. All right, we talked about zero error corrections, right? The negative error is simply when the Vernier scale division is to the left. That's when the zero on the Vernier scale is to the left of the zero on the main scale. We have to correct for that. All right. Now then, we also have the positive zero error. That's when the zero of the Vernier scale is to the right of the zero on the main scale. All right. So let's see how we correct for that. Okay, in a moment. Just in a moment. Okay. I may need to wipe this off now. Okay, or I may better still write this. So let's take for instance, this is the formula we would work with. Now, the actual value, right, when you measure an object, is simply the value you measure, that's the total value. This is the total value you measure, that's the total value of the objects you measure. Now, this has a minus. If before the measurement, we saw that when the jaws were closed, and it turns out to be that the zero on the Vernier scale is before the zero on the main scale, so that's the negative zero error. So it simply means, since the negative zero error has a minus, so it means I have to stick in the minus now, and in this case, it is 0.3, this is in millimeter. So it turns out to be that the minus times the minus would give us a plus. So what it simply implies is, to get the actual value, it is the total value plus the negative error, that's its in terms of its magnitude now, because the minus sign would cancel out to be a plus. Now, so this is plus 0.3 millimeters. And of course, we could tell what the total value of the object is in the moment, right? Since we haven't measured it. Now, but what if it had been a positive zero error? So the actual value of the object, the actual value of the object would be the total value, which you would see how to measure shortly, the total value. There's already a minus here, but the positive zero error in this scale is a plus 0.8 millimeter. So minus times the plus gives us a minus. So you always take note of this. Always take note of this, that when it is a positive zero error, you are removing the error. You subtract the error from the total value of the object you measured. That's for positive zero error. And if it's a negative zero error, you would add the magnitude of the negative error to the total value. That would give the actual value of it. Now, let's take for instance that I want to measure, let's say, the diameter of this marker, the outer diameter of the marker. Alright, so this is the main scale, right? And then this is the zero on the main scale, and let's say this is the zero on the Vernier. Okay, this is the zero on the main scale. This is main scale, this is the Vernier scale. And let's say this main scale is, let's say it's graduated in millimeter, right? Okay? So let's take, for example, I have some markings here. This is 1, 2, 3, 4, 5. Okay, this is 10, right? And this could go on and on, right? Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now I could start off from 0. Right? But of course, you could tell that I could just indicate what the value, right, on the main scale before the zero mark would be. So let's say this is 1, 2, 3, 4. And let's say this is 5 millimeters, right? 5 marks before the zero on the main scale. Is that correct? All right, so how do I really, so the object now that I'm to measure, that's distance of the object, right? Or the diameter of the object is from this portion, from this side to this side. So this is what I'm measuring. This is what I'm measuring. So how do I really measure this? Now let's see. This is let's say now the Vernier scale has, okay, I would fit 9 divisions now, right? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm fitting 10 divisions on the Vernier to fit 9 divisions on the main scale. So let's say this is 1, 2, 3, 4, 5. Now let's say the 6th mark, right, on the Vernier coincides with the main scale. This is 6, 7, 8, 9, okay, and let's say this is a 10, right? So let's say this is my Vernier scale, right? This is my Vernier scale, so to speak. But this is the point of coincidence, right? And this is 1, 2, 3, 4, 5, 6. This is the 6th mark. Okay, so how do I really tell what the diameter of this object is using a Vernier caliper, right? So it will be the N. N is simply the value on the main scale, main value on the main scale before the 0 mark. Before the 0 mark on the Vernier scale. On the Vernier scale. Just call that a VS. That's the N you see here, right? Then the little n you see in the previous formula, N is simply the Vernier scale division that coincides with the main scale division, okay? That coincides with main scale division. Alright. Then we have the least count. If it's in millimeter, we know it's 0.1 millimeter. And of course, if it's in centimeter, we know it's 0.01 centimeter. Alright, so we could take it off from here. I may need to wipe this off now. You may need to leave this for a while. Okay, now the total reading now, the total reading would be 5. This is, the formula is N plus N times LC. So N, the value on the main scale before the 0 on the Vernier is 5. And of course this is 5 millimeter plus N, the little n now is the Vernier scale division that coincides with the main scale. That's, we could see that this matches perfectly with the main scale. So that's the 6th mark. Times the least count. And of course this is in millimeter. So I will use 0.1 millimeter. If this scale had been in centimeter, I would use 0.01 centimeter. So let me use 0.1 millimeter. This would be 0.1 millimeter. Alright, so this would be 0.6 millimeter. And of course, I'm adding this to 5. I'll put it to 1 decimal place. Alright, so if I add up, this would give me 5.6 millimeter. This is the total. This is the total measure of the value of that object. Right? Okay. Now, let's now factor in, perhaps, before I took this measurement, okay? If I had a negative 0 error, what is implied is, let's say the 0 mark on the Vernier is to the left of the 0 on the main scale. If the two jaws, jaws A and B and jaws C and D, touch each other before, right, any object was measured. Alright, so let's assume that I had a negative 0 error. And let's take for instance that, okay, it was like we said earlier on, it is 0.3 millimeters. So I always say that the actual value of that object now is not really this, because we have to correct for the negative error. So this would be the total value, which is 5.6 millimeter. There is always the minus. We would always subtract. We would always subtract the 0 error, right, from the total value. We would always. But we do know that the negative error now, right, the negative error has a minus. So this is a minus 0.3 millimeters, right? This is minus, we need to clean this up now. So this is a minus 0.3 millimeters. So can you see that this would become a plus? So that was why I said earlier, and I said, just to save time, if you have a negative error, right, 0 error, just add the magnitudes, ignore the sign, to the total value of the object. You get the actual value. So this is 5.6 plus 0.3, of course. This is millimeter, this is in millimeter. So this would just give us, this would be 5.9 millimeter. This is the actual value of the object, not this, because we have to make room for the zero error. Now, what if it was a positive zero error? And of course, let's say in that case it coincided, you need to build this for a while. So let's say in that case, when we closed just A and B touched each other, there was no object in between, and the same goes with just C and D. But we found out now that the Vernier scale, right, the zero on the Vernier scale is to the right of the zero on the main scale, even when we hadn't any object in between just A and B or just C and D on the Vernier. So and then let's say, while that happened, we figured out that it was the 8th mark on the Vernier, right, that merged with the main scale division. So what do we simply do? Since the total value is 5.6 millimeter, and there's always a minus here, right? So the positive zero error implies it has a positive value, right? So minus times that positive value will give us a plus, right? So that number of the main scale division that merges with the number of the Vernier scale division that merges with the main scale division times the least count. So let's say this is in millimeter now, so this will be the 8th division from the previous example times the least count, and this will be 0.8 millimeter. So if you subtract, you get 5.6.8. This is a 4, this is a 16, this is 8, this is a 4. So this will give us 4.8 millimeter. So the actual value of that object that was measured will not be 5.6, but it has to be 4.8 because we have to make room for the positive zero error. All right, having talked about this now, we may need to switch now to the micrometer screw gauge, which could measure the diameter. Now, the micrometer screw gauge measures the outer diameters of round objects only. Only the Vernier could measure both the outer, the inner, and of course, the depth of hollow in an object. But for the micrometer screw gauge now, which I'm about to talk about shortly, this can only measure the outer diameters of round objects, and also it could measure the thickness of very small objects. For example, the thickness of a piece of paper, thickness of a wire, so to speak, okay? And of course, what have you. Now, the micrometer screw gauge. Now, micro is 10 to the power minus 6. We'll see that shortly, the micrometer screw gauge, okay? Now, this is just a scale, right? This is a scale that has a nut here. Then I have screws, right? Finely threaded screw. So I have finely threaded screw. This is a nut. Okay, this is another nut here. Okay, let me do this. This is a nut. So there is a strip, a metallic frame here, right? The same goes with this. There's another metallic frame here, like so. There is a frame here, right? Then I have a scale. I have a linear scale here. A linear scale. I will explain this shortly. I also have a circular scale here. I have a circular scale with some markings like so, right? Then I have a ratchet, just like a screw, okay? All right, now there is a nut here, and this micrometer screw gauge works with the principle of the fact that I could fit accurately, finely threaded screw into these nuts. All right, so for the sake of time, I may need to stop here, and I'll proceed from here from the previous class. If you're new to the channel, you want to like, share, and subscribe for more content. Thank you.